more separation of variables, getting a little bit more involved. For given this, y of 1 equals 0, and given the equation here, and noting that f of x or y equals 1 plus y squared over x squared equals this all squared, is a function of the ratio y over x, such that f t of x and t of y equals 1 plus t of y over t of x squared equals f of x of y. We need to substitute y equals u of x, for which y over x equals u. Now dy over dx equals 1 plus u squared. Applying the chain rule, we get dy equals dx plus u squared dx, implicitly differentiating both sides of y equals u of x, and applying product rule to get dy equals u dx plus x du. In the above equation, we replace with u dx x du. We'll replace it with this because we want something of this form, which matches up and brings, I don't know what I wrote there, brings to the right hand side, bringing this to the right hand side and factor out dx, we get this. We separate variables and integrate. Separating variables, integrating, it's all pretty straightforward. We get this ln of x plus c. Now the left hand side, we'll complete the square, which gives us this. Or we could make the substitution 1 minus u minus 1/2 equals root 3 over 2 tangent theta, such that du equals root 3 over 2 secant squared theta d theta. The reason for that is that this, from completing the square, equals this, which equals this, this plus this. By the trig identity, 1 plus tangent theta equals secant squared theta. Now we replace u squared minus u plus 1 in the previous equation with 3/4 secant squared theta, and replace du with root 3 over 2 secant squared theta d theta. Now we're putting this in top and bottom of this divisor within our integral, which equals ln of x plus c. And we note that with our arithmetic we get this 2 root 3 over 3 and 2 root 3 of 3, since root 3 over 2 equals this equals 1 over root 3, and we get this here from our integral, and theta 2 over root 3 theta equals this, and we're going to multiply through to get our theta, and multiply u by u dot 1/2 equals root 3 over 2 tangent theta by 2 to get 2u minus 1 equals root 3 tangent theta. It follows that theta equals the inverse tangent of 2n minus 1 over root 3. We substitute into the equation for inverse tangent 2u minus 1 over root 3 equals root 3 over 2 ln of x plus c, and we take the tangent on both sides to get this. So 2u equals this and u equals this once dividing by 2, and recall that u equals y over x as we first established, so we need these values back in, which gives us this, and multiplying through by x we get our y as our solutions here. Now we deal with the boundary conditions, which we initially started with. Y of 1 equals 0. To find a constant, plug in x equals 1, y equals 0, and record that logarithm of 1 equals 0. So we get this. And going through a little bit of algebra, our c value as this. Now for this case, our absolute value of x is greater than 0 for the logarithm, and the final answer is given here. And that's more separation of variables. Please do like and subscribe.